You are all welcome to this PowerPoint presentation. Today, we are focusing on forced draft cooling towers. Here on the slide, we have the key components of a forced draft cooling tower. 1. Fans and motors. They create the forced airflow needed for heat dissipation. 2. Film media. Provides surface area for water-air interaction, enhancing evaporation. 3. Drift eliminators. They minimize water droplets carried away by exhaust air. 4. Louvers. They control air intake, reducing water loss due to splashing. 5. Cold water basin. It collects the cooled water before recirculation. 6. Pump and piping system. Ensures water circulation throughout the cooling cycle. Introduction. Forced draft cooling towers used mechanical fans to force air through the system, enhancing heat dissipation. In industrial and HVAC applications, unlike natural draft towers, they provide controlled airflow, ensuring efficient and consistent cooling. Their compact design, reliability, and adaptability make them ideal for industries requiring precise temperature and regulation. These cooling towers are widely used in power plants, chemical processing, and manufacturing facilities, where effective heat rejection is crucial for operational efficiency. Additionally, their ability to function in various environmental conditions makes them a preferred choice for modern cooling systems. They offer advantages such as lower water consumption, improved energy efficiency, and reduced environmental impact, making them essential for industries focused on sustainable and cost effective cooling solutions. Types of forced draft cooling towers. Forced draft cooling towers use fans to force air through the system, improving heat dissipation. The main types include 1. Induced draft cooling tower. 2. Cross flow forced draft cooling tower. Counterflow forced draft cooling tower. And mechanical draft cooling tower. Induced draft cooling tower. An induced draft cooling tower is a mechanical draft cooling tower that uses a fan at the top to pull air through the system, improving heat dissipation. It operates on evaporative cooling, where hot water is distributed over film media and airflow removes heat, cooling the water for reuse. Advantages. It has high efficiency, reduced air recirculation, a compact design, and a better control. Disadvantage. Has high energy consumption, regular maintenance, and noise issues. The applications. It is used in power plants, refineries, HVAC systems, and industrial cooling. Cross-flow forced draft cooling tower. A cross-flow draft forced draft cooling tower is a type of cooling tower when where air flows horizontally across the fallen water and fans located on the side force air into the system. This design allows efficient heat exchange while maintaining easy maintenance, access to the fans and mechanical components. Advantages. Reduced splash loss. Water flows smoothly without turbulence, reducing water loss. Lower energy consumption. Requires less fan power compared to induced draft systems. Disadvantage. Less efficient in windy conditions. External air currents can affect its performance. Higher risk of recirculation. Discharged air may re-enter the system if not properly positioned. Application. 1. HVAC systems. Cooling for commercial and industrial buildings. Chemical and petrochemical plants. Cooling process fluids. Food and beverage industry. managing heat loads in manufacturing processes. Then power plants, cooling auxiliary systems, counterflow forced draft cooling tower. It is a type of cooling tower where air is forced into the system by fans and moves vertically upwards against the falling water. This counterflow movement enhances heat exchange efficiency, making it suitable for industrial and HVAC applications. Advantages: 1. It has higher cooling efficiency. Air moves directly against water flow, maximizing heat exchange. 2. Compact and space saving. Requires less footprint compared to cross-flow designs. Disadvantages: 1. Has higher fan power required. Forcing air upwards requires more energy. More complex maintenance. Fans and motors are enclosed inside the unit. Mechanical draft cooling tower. A mechanical draft cooling tower is a cooling system that uses fans to actively force or draw air through the tower, improving cooling efficiency. Unlike natural draft cooling towers, which rely on airflow from temperature. Differences: mechanical draft towers provide control cooling by using external energy to drive airflow. Advantages: 1. Has controlled airflow, ensuring better cooling. 2. Requires less space than natural draft towers. Disadvantages: has higher energy consumption. 2. Fans can produce significant noise, requiring soundproofing solutions. The working principle of forced draft cooling towers. The operation of a forced draft cooling tower follows a structured heat exchange process. 1. Hot water distribution. Heated water from industrial processes, power plants, or HVAC systems is pumped into the cooling tower. The water is sprayed or distributed over the fill media, increasing surface area for heat exchange. 2. Forced airflow introduction. At this stage, high velocity fans, typically located at the tower's base or along its sides, push ambient air into the system. This forced air moves in a cross-flow or counter-flow pattern relative to the water. 3. At this stage, heat exchange process. As air passes through the tower, it absorbs heat from the water, facilitating evaporative cooling. Some water evaporates, taking away latent heat and cooling the remaining water. 4. Cooled water collection. The cooled water drips into a collection basin and is recirculated back into the industrial process. 5. Warm air discharge. The moisture-laden air, now carrying heat from the process, is expelled into the atmosphere. Louvers or drift eliminators minimize the water loss through excessive misting. This diagram shows how clearly the forced draft cooling towers work. The advantages of forced draft cooling towers. 1. Compact and space efficient. It requires less space compared to natural draft cooling towers, making it ideal for industrial and commercial applications with limited area. 2. Higher cooling efficiency. The forced airflow ensures consistent cooling performance even in variable environment conditions such as high humidity or low wind speed. 3. Better control over airflow. Fan speed can be adjusted to optimize cooling efficiency, reducing unnecessary energy consumption when full capacity is not required. 4. Less affected by external weather conditions. Unlike natural draft towers, which depend on atmospheric conditions, forced draft towers provide stable cooling regardless of ambient temperature and wind speed. 5. Suitable for high heat loads. It is capable of handling large cooling loads, making them suitable for power plants, chemical plants, steel mills, and HVAC applications. lower water consumptions compared to induced draft towers. It has more efficient water distribution and drift eliminators, reduce water losses due to evaporation and misting, quieter operation. Since fans are typically located at the base of the unit, noise levels are lower compared to the induced draft cooling towers where the fans are at the top. 8. Prevent circulation of hot air. The design reduces the chances of warm discharged air being pulled back into the system, ensuring more effective cooling. 9. Adaptability to various industrial applications. Used in power generation, HVAC systems, food processing, chemical processing, and other industries requiring reliable cooling. 10. Durability and longevity. With proper maintenance, forced draft cooling towers can provide long-term reliable service with minimal performance degradation. Disadvantages of forced draft cooling towers. 1. We have higher energy consumption. The use of mechanical fans requires a constant power supply, which leads to increased operational costs compared to the natural draft cooling towers. Increased maintenance requirements. Fans, motors, and other moving components need regular inspection, lubrication, and servicing to prevent breakdowns and ensure efficiency. 3. Potential recirculation issues. If properly designed or placed, discharged warm air can be drawn back into the system, reducing cooling efficiency. 4. Limited scalability of large installations. Forced draft towers are generally better suited for medium-sized applications, as larger cooling loads may require more powerful fans and increased energy consumptions. 5. Higher initial cost compared to natural draft towers. The inclusion of mechanical fans and motors increases the upfront cost of installations. 6. Possible noise contents. While quieter than induced draft towers, forced draft towers systems will generate fan and motor noise, which may require additional noise control measures in noise sensitive environments. Economical, economical considerations. Capital costs. 1. Higher initial investment due to fan and motor systems. 2. Installation expenses include electrical components, piping and controls. 2. Operating costs. An operating cost. We have electricity consumption for the fan operation, which leads to ongoing expenses. Water treatment costs for preventing scale buildup and biological growth. Routine maintenance and repairs for mechanical parts. 3. Long-term savings. Optimized energy use with variable frequency drives VFDs can reduce electricity costs. Efficient cooling leads to improved industrial productivity and reduced downtime. Future developments and innovations. 1. Energy efficient fans designs. Using EC, that is electronically commutated fans to reduce power consumption. 2. Smart monitoring systems. IoT based sensors for real time performance tracking and predictive maintenance. 3. Sustainable cooling solutions. Hybrid cooling towers that integrate dry and wet cooling for better efficiency. 4. Improved water treatment techniques. Advanced filtration and chemical free treatment to reduce environmental impact. Conclusion. So, forced draft cooling towers provide an efficient and controlled method for heat dissipation in industrial and HVAC applications. By using mechanical fans to push air through the system, these towers ensure consistent cooling performance regardless of environmental conditions. Their compact designs makes them suitable for space-constrained installations, while the ability to handle high heat loads makes them ideal for power plants, manufacturing, and other industries. However, they require regular maintenance and consume more energy compared to natural draft alternatives. With proper design, operation, and upkeep, forced draft cooling towers can offer reliable and effective cooling, contributing to improved efficiency and sustainability in various sectors. Thank you.